technology day on the F-test, or when you're using two variance or two standard deviations. And like usual, I'll give you one example and work through it on the calculator and also on StatCrunch and see which one you like best. I think you'll like StatCrunch better today, but we'll see. Problem says we were given body temperatures from 8 a.m. on a certain day, and the stats are given in the table below. Use these data with a 0.05 sig level to test the claim that men have body temperatures that vary more than the body temperatures of women. Okay, so which one varies the most? And you got the stats down here. And as you're looking at those, remember the reason the men comes first because it says N1, X1, S1. Remember from yesterday that the one with the bigger variance, and if you square both of these, this one will still be bigger, is always the first one, the one that goes on top of your F of the fraction. The women come second because the variance would be less than the first one. Here's our Ho and our Ha. The Ho is always population variance is equal to population 2 variance, and this one said that the men vary more than the women, so I'm using greater than. Okay, so kind of keep those things in mind. We'll refer back to them if we need to, but let me show you the calculator first. The calculator has one drawback in that in order to find the to find the critical value, you have to download a program, which we don't have right now. So you can get it from somewhere. If you see it online or something, you can download it, but I don't have it on here, and so it's kind of limited. So I'm going to show you what it does anyway. Go to Stat, Test, and just scroll down until you find, mine's just scrolling on its own right now. Right there, E, two sample F test. Okay, two sample F test. So hit enter. When you get there, we go on the stats, and to save time, I've already entered the numbers in here that it asks for. All it asks for is the sample standard deviation and the N, the sample standard deviation and the N. Make sure you get those in the right order. The biggest one should come first. I've already highlighted greater than, so I'm going to go to calculate, and just like that, it's going to give me all I need. It gives me first of all, it tells me up here that I did greater than. It gives me the F statistic, or the test statistic. It gives me my p-value 0.07, which is higher than 0.05. So just with that fact alone, I already know I'm going to fail to reject the null. But the problem with the calculator is I can't find the critical value to compare the F-stat to, because if you go to second vars like we always do, there's no inverse F. You could scroll all the way down. There's an FPDF and FCDF, but there's no inverse F. So you cannot find, without having a program or downloading a program from somewhere, how to find the critical values. So it's kind of limited a little bit. So that's the calculator steps. All right, now StatCrunch. StatCrunch, the great thing about StatCrunch is I can go to calculators, and there's an F right there, and I can go type in the information I need to get the critical value. So I'm going to do that first. The numerator degrees of freedom, remember that's the bigger one. It's 10. There were 11 men, so I'm putting 10 there. The denominator, there were 59 women, so I'm putting 58 there. I definitely need greater than. I said the men are greater than the women, so I'm going greater than. I need to clear this out, and it's a 0.05 sig level, and it was right tail test. So we hit compute, and just like that, this number right here, the 1.9983476, and it even draws a picture for you there of the right tail. Remember, F distribution is right skewed, like that picture is, and so that's my critical value. And remember, I just found the test stat on the calculator a second ago, and it was like 1.8. So again, that's going to be failed to reject. So let me show you how to get the other stuff here on StatCrunch. That's the critical value, though. That's the number right there on our curve when we draw our picture. All right. To find the F-stat and the p-value on StatCrunch, you're going to go to variance stats, to sample, with summary, and we're going to type in what we know. The variance for the first one was 0.89 squared. You do need to square them before you put them in here. The 0.89 that it gave me in the problem was the actual standard deviation. So if you square it, you get 0.7921. Sample size was 11 for the men. Variance 2 was 0.66 squared. I'm actually squaring these as I'm talking to my calculator. Getting 0.4356. And then the sample size for the second one was 59 for the women. All right, now come down here. I want the difference here. Well, I want that to equal 1 every time, which means they're the same. You know, my hope is that they're the same or they're equal, and if they're equal and you put one on top of the other, you will get 1. So that always is equal 1. So we want the men greater, so that means the top should be greater than 1, or should be greater than the bottom, which means it's going to be bigger than 1. So we hit compute, and I get the same exact F stat, or it's our test statistic, and P value that I got a minute ago. And again, that F stat right there is bigger. Sorry, it's not as big as our. See if I got this still here. I think if I click on this, yeah, that was, well, it's not there anymore. So that was 1.9, I think. I can't remember. But anyway, that's not in the region. Let's see if I can try one more try here. Sorry about that. I'm going to try one more, see if I can find the one that I had maybe. There it is. So it's that was 1.99383. So this test out of 1.818 would be right around here. So it would not be in the rejection zone. So I would fail to reject the null. And if I fail to reject the null, let's go back and look what that was real quick. There it is. I'm failing to reject that. And the claim was that the mean body temperature, so the Ha was the claim. And because I'm failing to reject that, I would say there is not sufficient evidence to support the claim that the men's temperatures vary more than women's temperatures do. All right. And that's really it. That's all the technology. StatCrunch does everything. So I think that may be the better way to go tomorrow in class. But your calculator will do it all pretty quickly, except for it won't give you the critical value, which is kind of important. So we'll probably use StatCrunch mainly. So I'll see you in class tomorrow. Thanks.